Okay, so the function is very nice. So what we need to find the inflection point is that find f double prime. Oh, by the way, the function itself is not given. This is f prime given. And since I need f double prime, I just need to differentiate f prime one more time. So here, derivative of, oh, this is product of two things. So I will use the product rule, minus x cubed prime. Derivative of first one times the second one plus the first one itself times the derivative of the second one. Okay, so this will be minus 3x squared e to the power minus x squared over 2 minus 2x plus 3. And that will be minus x cubed e to the power minus x squared over 2 minus 2x plus, oh, sorry, I have to differentiate that. Remember, this is a good point to recall that derivative of e to the power u is u prime e to the power u. So I will have derivative of minus x squared over 2 minus 2x plus 3 e to the power the same. So this will be minus 3x squared. Well, right away here, you notice that the first term and the second term, both of them has this factor of e to the power minus x squared over 2 minus 2x plus 3, yes? So you can factor that part. And from the first piece, you get minus 3x squared. From the second one, this minus x cubed, differentiate this part. This is minus x squared. Minus x squared over 2, differentiate, you get minus x. Minus 2x, you get minus 2. Okay? So let's just multiply that. So I will have minus x cubed times x minus x, this is x4. Then I have minus 3x squared, and then multiply this another one plus, okay, plus 2x cubed minus 3x squared. This is the second derivative of the function. Okay. Now, I should set this one equal to 0. While setting this guy equal to 0, I noticed that, okay, so this either that part is 0 or, let's see, there's a factorization that we can do here, yes? I can factor out x squared. Inside will be x squared plus 2x minus 3. And then I can factor out this part. It will be adding, you get 2, multiply, you get negative 3. So it will be x plus 3, x minus 1. There's x squared. So let me just write f double prime again. F double prime of x is going to be x squared, x plus 3, x minus 1. E to the power minus x squared minus 2x plus 3. And if we set this guy equal to 0, now I can bring that down and pretend that I was trying to write it there. So either this part is 0, or this part is 0, or this part is 0, or this part. From, oh, why did I put equality up there? This should be, the whole thing must be equal to 0. E to the power, any number you take, it never vanishes. You never have e to the power any number you like, or real numbers. never gets a 0. That's good. From this other ones, you get x is either -1, or x is -3, or x is 0. So these are only candidates for inflection points. We have to make sure that the sign of f double prime changes when we pass these points. See which one change, at which one change. So we
It's
need,
x minus 1.
sorry.
It's x minus 1, not x plus 1. So it's x is equal.
Oh, I see. Thank you. That's good. Thank you. So this is -3, 0, and then 1. And we want to see where this guy, what is happening here on the signs of these guys. Another thing is good to note here is that e to the power something not only is always non-zero, it is always positive. X squared is something non-negative, so the sign will depend only on this part. And if you do evaluate on the sample values, you will notice that it will be positive here, negative here, and then positive here. So you just need to evaluate in some values, and then you will go find those ones. Yes. Now, at so that means that, oops, f on the interval from -infinity to -3 is positive. Here is negative. If double prime is negative, it means that this is concave down, and here it's concave up. And you see that at 0, the concavity or the sign of f double prime doesn't change. So this is not an point of inflection, but f has points of inflection with first component equal to -3 and 1. So not all the points which make the second derivative 0 will give you a point of inflection. You have to make sure that f double prime changes the sign, or equivalently, f itself changes the concavity in the graph.